Okay, since students are doing homework tonight, I wanted to make sure that they had some good examples to use. So I'm going to go ahead and work on some of those teamwork items that the students had time to work on in class, just to make sure that they have some good models to do at home. Now, the first item says Hazel looked at a map and saw that she walked from point A, -8, -2, to point B, -5, -2. If each unit equals 1 mile, how many miles did Hazel walk? Now, I'm going to make a model just because I feel like a lot of students are visual learners and they need to see that model in order to make sure that they get a good answer. So I'm going to make my model something like this. Okay. Now, I'm making my model of a coordinate plane like this because, well, you'll see in just a moment. When we have A at -8, -2, that -8 would be right around here on the x-axis. And -2 would be, well, here could be -1, and here could be -2 on the y-axis. So our point for -8, -2 could be right there. It could be right there. And with B, we have -5, -2. So let me go ahead and fill these in. So that's 8. Okay. Go ahead and put this. Now this isn't drawn to scale, of course, but so here we have -1, -2, -3, -4, -5. And here is -1, -2, so it would be right about here. And this is -6, -7, -8. So when I do it this way, make my model, it's not too hard to then look and see how many units separate point A from point B. I can see that there are actually 1, 2, 3. That A is 3 units away from B, and 3 units would be equal to 3 miles because each unit equals 1 mile. So we could say how many miles did Hazel walk? I could say that she walked 3 miles. Now there's another way we could have solved this problem as well. If you'll notice this -2 on the y-axis and this -2 on the y-axis, since they're both on the same axis, we have -2, -2. We know that the numbers that we need to worry about are -8 and -5. So we could have just simply said the absolute value of -8, subtract the absolute value of -5, and that's going to be 8 take away 5, which is 3 units, and 3 units are equal to 3 miles. That's a much faster way than using a model, but I wanted to show both ways in case there were students who needed to see that model to make sure that they were doing it correctly. All I would focus on is if you can find a number that's the same, whether it's the y-axis here, where we have -2, -2, or maybe they might put it on the x-axis sometime. But when you have the numbers the same on the y-axis, you're going to have like a horizontal line. If the numbers are the same on the x-axis, you would have more of a vertical line, if that were the case. Okay, let's go ahead now and look at number 2. Okay, number 2 says, Dinah has designed half of a badge for her jacket. Use the x-axis as a line of symmetry to complete Dinah's badge. B, what is the distance between point A and point B on her design? Okay, I'm going to make sense of the problem by coming up with a plan. I'm going to work my plan out step by step. I know that this, what looks like a triangle here, is going to actually make like a diamond because I'm going to reflect what we see here, this point, primarily this point. I'm going to reflect it and put it over down here, and you'll see. Now, since the x-axis is 0, 0, and the opposite of 0 is itself, I'm not going to have to do a whole lot with those points. I'm going to have to focus mostly on this point C. And after I do that, I'll worry about part B. So the first thing I want to do is I want to identify the points that are really important. I want to identify those points that are really key here. And one of them would be this point here. Now this point, I'm not going to have to worry about it too much because that point, it's on a zero. So since it's on a zero x-axis, I know I'm not going to have to do anything with it other than just connect it. And here's at a zero x-axis. So once again, I'm not going to do anything with it. So if I have a coordinate here, 0, 9 for C, and 0 being the x-axis coordinate, and since we are using the x-axis as a line of symmetry, that 0 is going to stay the same, but I'm going to have to do the opposite of positive 9. The opposite of positive 9 is negative 9. So my new point, which will be D is going to be located at 0 and then negative 9 on the y-axis. So here is 0, and I'm going to go straight down to negative 9. And there's where negative 9 is. Now all I have to do is just connect the point here at A with point D. And I guess I better go ahead and label that as point D. And I'm going to go ahead and say it's 0, negative 9. And that's a comma. Okay, so let's go ahead and connect those points. I'll do this very, very carefully. I want to be precise here, which is another thinking like a mathematician practice, number 6 as a matter of fact. And because I was precise, now the badge has that diamond shape. So here would be A, point A, C, B, D. Now, this is what the badge looks like completed. Now I have to address part B. What is the distance between point A and point B on her design? Now, a minute ago I talked about how look for where you have a value that's the same. And here I have 0, 0 on the x-axis. And so 0, 0 on the x-axis, what I need to do is focus on negative 5 and positive 5. Now a minute ago, I had a situation where I had a point at negative 8, 2 right here, and then I had negative 5, 2 right here. And because we were in the same quadrant, in this case we're in quadrant 3, quadrant 1, quadrant 2, quadrant 3, quadrant 4, since we're in the same quadrant, all we had to do really was we just had to subtract absolute values. This time, since we're going from one quadrant to another, instead of subtracting absolute values, we're going to add absolute values. We're going to add them. So this is what that's going to look like. So negative 5, I'm going to take absolute value of negative 5. I'm going to add to that the absolute value of positive 5. And that's simply 5 plus 5, which is equal to 10 units. So the distance between point A and point B on her design is 10 units. Now, if I had a better control of my pen here, I would actually write that out. I would actually say the distance between point A and point B on Dinah's design is 10 units. And that's the type of response I would expect out of my students. But since I don't have control of it, you'll just have to listen to it orally. Now, another way that we could have done it besides just simply adding the absolute value of negative 5 and positive 5 is just going from like this point and counting units that way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I could have done it that way if I chose. Okay, now we have number 3. Let's look at this one. It says Bobby needs to figure out where to place a point to make his shape a rectangle. His first 3 points are W at 4, 2, X at 4, negative 1, and Y at negative 9, negative 1. A says, where does point Z need to go to make the shape a rectangle? And B, if each unit equals 1 centimeter, what is the distance between point X and point Y? Okay, it's just so easy to make a model. And Since this type of problem, for some kids, they really need that model because we're going to be working with more than one quadrant. I'm going to go ahead and make one at this time. So I'm going to go ahead and make a y-axis here. And because I know my y-axis are going to be 2, my y-axis coordinates are 2, -1, -1. I could have had a really shallow y-axis, but I'll make it like that. My x-axis, though, since I have coordinates like +4, which would be like over here, and then I have -9, which could be way over here, I'm going to make a pretty long x-axis. Okay. Now, let's go ahead and make some notches on here. So W is at +4, +2. So here's the x-axis, and here would be +1, +2, +3, +4. So here's where +4 would be, and 2. So +1, +2 for the y-axis. So that's going to put that point right about here. So this is where we'll have point W, and that's going to be located at 4, 2. Now let's look at x, +4, -1. So here we're at +4 again, but this time we need to have -1, and -1 is going to be right here. And I'll put that point right here, and that's going to be x, and that's going to be 4, -1. Now let's look at y. Y has -9, -1. So let's go over here. Let's see, 1, -1, -2, -3, -4, -5, -6, -7, -8, -9. Okay, so this was -9, and this is -1. So I'm going to go ahead and put my point for -9, -1 right here. And that's going to be point y. And y is located at -9 and -1. Now, we need one more point to make a rectangle. One more point. And we know that y and x will make one side. X and w will make another side. We need to put point z here so that we can have point yz and point wz, side wz. So that point needs to go right about here to make it a rectangle. And just to see if it'll work, I'm going to try making a box. This is something that I do sometimes. I'll just make a little box and see if I get it. So I'm going to have to have my point right there. And that point that's right here, I see it's located at -9 on the x-axis, and it's located at +2 on the y-axis, and that's going to be point z. And here's my rectangle. Now, one thing I would like to say I could have done besides make a rectangle, and when you've got a piece of paper and you're working this out, you can't just start here and drag out a rectangle like that. What you could do is just, if you see that you have -9 here, you know you're going to have to go stay on -9. And if you have +2 here, you're going to have to just stay on that +2 and bring it over here just to make that point. It just has to be that way. I mean, most kids can look at it in mental math. They can just look at it and tell that's going to be right there, because if you're here and there, you're going to have to take those 2 points and bring them over until they intersect. And at that vertex is where you'll have your 4th corner. Okay, now B says if each unit equals 1 centimeter, what is the distance between point X and point Y? Okay, so here we have point X and here we have point Y. And just like a moment ago, when we went from one quadrant, this time quadrant 4 here and quadrant 3 here, if we go in from one quadrant to another, all we do is we add the absolute values together. So here we have absolute value of -9 plus the absolute value of 4, and that's going to be 9 plus 4 equals 13. We know that's 13 units. If we wanted to, we could have counted them. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we got the same answer, but We can't just say that the distance is 13 units. We have to say that each unit equals 1 centimeter, so the distance is 13 centimeters. 13 centimeters. Okay, so I did 3 examples from our group work that the students were working on, and I feel like after doing these 3 examples, students should be able to get a really good start on their homework. I hope that this video has helped you out.